Okay, we've talked about similar polygons. What we're going to do today is we are going to talk about, more specifically, not just any old polygon. Because what did we do today? We dealt with, in that homework, you had triangles, 3 sides. You had quadrilaterals, 4 sides. And the last problem that we worked on together was a polygon, which is 5 sides. But today, we're just going to concentrate just on triangles. In geometry, you do a lot of stuff with triangles. So we're just going to talk about similar triangles, not just any similar polygon, specifically triangles. Let me grab a triangle, put it right there, and let's make this a little bit bigger. Put that small one right next to it, that right there. Let's talk about these triangles. Let's label them first. It's A, B, C, and D, E, F. Now, up to this point, they've pretty much told you that these triangles were similar to each other, or the polygons were similar. So what two things must be true about similar polygons? Do you remember? The corresponding angles have to be what? Equal to each other, right? So the corresponding angles. So which ones look corresponding to you? If I pick this one and put it up here, the A and the what? The A and the D would equal, the B and the E and the C and the F would equal each other, okay? So the corresponding angles must be equal. What's the second thing we learned about similar figures or polygons? We said that the corresponding sides had to be what? Are they equal as well? They're in proportion. Very good. Okay. In proportion. All right, so the corresponding sides must be in proportion if they are similar to each other. But the thing is, now on this lesson, I'm not told that they're similar to each other. Okay, I'm just given a certain amount of information about these two triangles, and we have to determine if they're similar to each other or not similar to each other. Okay, and we basically have 3 ways that we're going to learn today anyway. 3 ways that we're going to learn to see if these two triangles are similar. This is going to look, sorry for the use of this word again, but it's going to be very similar to what we did back when we did congruent triangles. Remember doing congruent triangles? Remember we had side, 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 postulate, we had side, angle, side angle, and all that good stuff. Remember that? It's kind of the same as that. Okay, it's going to be very close to that, or very similar to that. All right, sorry. It wasn't supposed to be a joke, but it was just kind of funny that we're using similar triangles. All right, so let's do the first one. What if I gave you some information? Now, right now, just these triangles sitting there right now, you have no idea if they're similar, do you? I mean, they might look like it. You're like, yeah, it looks pretty much the same shape. It looks a little smaller than this. So, yeah, they probably are similar. But do you really want to go by probably? Not at all. You want to know for sure. So here's a surefire way to tell if these are similar to each other. If I was told, let's write this down. If I was told that angle A was equal to angle D, so if somehow they told me that was true, that angle A was equal to angle D, and angle B was equal to angle E, right there is enough to say that my triangles are similar to each other. I don't even have to say anything about the sides being in proportion. Okay? All I have to be able to do is show that 2 angles of one triangle equals 2 angles of another triangle, and if I'm able to show that, I can say those triangles are similar. I don't have to know anything about the sides. Okay? All I got to know is 2 angles here equal 2 angles here. Bang. That's enough to say that they're similar. So let's finish this off. If angle A equals angle D and angle B equals angle E, then what do you think I can say about the triangles? The triangles are similar. So then I could say triangle ABC is similar to triangle DEF. Now, if I know that they're similar to each other, now I could also say a whole bunch of stuff. I could say angle C equals F, right? Because all the angles are equal. I could also say, could I say that AB equals DE? No, because it's definitely not. That's way bigger than that, okay? But I could say that AB over DE, right, equals AC over DF, which equals BC over EF, couldn't I? That would mean that the sides are in proportion. And we've talked about that. I'm not going to write that down. I wrote that in the other class, but now that I'm thinking about it, I don't think I need to write that part down. We have a name for this. two angles of one triangle equaling two angles of another triangle. We call this the angle-angle. Now, we don't just call it the angle-angle postulate or anything. We call it the angle-angle similarity postulate. Remember, a postulate does not have to be proven. It's an accepted fact, okay? And the reason we put similarity in here, because the triangles are not congruent to each other. They are what? They're similar to each other. So we call it the angle-angle similarity postulate. Does that make any sense? All right. And that's all you have to know, right? In order to say that they're similar. Well, there's a couple other ways to show that triangles are similar to each other. I'll tell you what, let's get rid of that. Let's go back and just copy. I'll just use the same triangles and everything just to make it consistent. All right, so there we go again. Let's make it a little thicker. There we go. Here's another way. What if I said that, let's use the same letters, A, B, C, D, E, F. All right, so every time we do this, we'll just use the same triangles, the same letters. So I don't know anything about this right now, do I? I don't know that any angles are equal. I don't know any sides are equal or in proportion. I don't know anything about this thing. All right, but what if they told us some stuff? So let's go a different color here. What if they told me that AB over DF, I'm sorry, don't write DF, DE. Sorry, I'm getting ahead of myself. What if they told me that AB over DE was equal to, let's say, AC over DF. Now I'll put the DF right there. And that's also equal to BC over EF. See all that stuff right there? And you say, well, that doesn't make any sense. I don't understand. How would you know that this over this equals this over this? Okay, well, let's put some numbers in here. We'll just try to make this pretty easy. We'll call that 10, call that 8, and we'll call that 6. All right? And I'm just making this as easy as I can. We'll call that, this is not really going to work because this will be a right triangle, but that's okay. We'll do it anyway. That's 4 and this is 3. That's good enough for us. Because the 3, 4, 5, remember talking about 3, 4, 5, it should be a right triangle. That doesn't even look like a right triangle, does it? But we'll just go with the numbers instead. So what if we had this? Look, AB over DE. That's what? 8 over 4. Now, what if that equals AC over DF, which is 10 over 5? And what if that also equals BC over EF, which is 6 over 3? Look, what do all three of those actually equal? What's 8 over 4? It's 2. It's 10 over 5. It's 2. What's 6 over 3? It's 2. Look, they all equal each other, don't they? Do you see that? So that must mean, what's true about the sides then? The sides are in proportion. So, if the sides are in proportion, that's all that mess right there. That's what it's saying. If the three sides are all in proportion, if they have the same scale factor, which they do, don't they? 2 over 1 or 2. If the sides are all in proportion, then guess what might be true about these two triangles? They're similar, exactly. So we'll go ABC is similar to triangle DEF. I didn't know anything about the angles this time, did I? Do you remember the other one? The other one that we talked about, I didn't know anything about the sides. I only knew stuff about the angles. This one, I don't know anything about the angles, but I know everything about the sides, don't I? And I know if I compare the corresponding sides, they all equal the same thing, which means they are in proportion. So, if the three sides are in proportion, then they're similar triangles. So what do I know? Now, originally I didn't know anything about the angles, but now I know that they're similar. So what do you think I can say about angle A? It's got to be equal to angle D. Does it make sense? What about angle B? That has to equal what? Angle E. Even though they didn't tell me that at the beginning, right? I can figure that out since I know they're similar. And then, of course, angle C and angle F would be equal to each other as well. We good with that? Yeah, we've kind of done stuff like that before. What do you think they call this? It has nothing to do with angles, is it? But all three sides are in proportion. So what do you think we're going to call it? We call the other one angle-angle similarity. So what do you think we might call this one? Side, side, side. But not just side, 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 because they're not congruent, Well, what do you think we're going to call it? Side, side, side what? Similarity. Good. Just forget to dot my I's. Okay, so side, side, side similarity. Now, this is not a postulate. It's a theorem, but I don't really care if you know it's a postulate or a theorem. It can be proven. We're not going to prove it in here, but it's just a slight difference. But I just want you to know side, side, side similarity. That's it. Now, does that mean that all three sides are equal to each other? No. Does that mean all three sides here equal all three sides here? No. But it does mean that the sides are all in proportion. All three sides are in proportion, which means they have the same scale factor. All right? There's another one. Let's do the same two triangles. And you're given a little different information. Again, let's label them just like we've been labeling. Call it ABC. Sorry we're not any more creative on this, but that's all right. Kind of like consistency sometimes, don't you? What if they told us this? Now, again, right now, sitting in front of us right now, they didn't tell us anything about these triangles. I don't know anything about the sides. I don't know anything about the angles. But what if they told us, let's go to this purple color. What if they told us that, put a big if there, that AB over DE was to equal AC over DF? Is that enough right there to say that these triangles are similar? Is that all three sides being shown in proportion? No, it's not. It's only two of them. So that's not enough in and of itself. Okay? But they tell you one more thing. They also tell you, they put and angle A equals angle D. So let's mark this. Now, the way I'm going to mark the sides is not anything the way they mark them in the book. They never do it like this. I just kind of came up with this on my own, all right? So I'm going to put one tick mark here, but that's a big old tick mark. You see that? It's a little extra large tick mark, okay? So what do you think I'm going to put here? A little tiny tick mark, okay? Does it mean that those two sides are equal to each other because they both have one tick mark? No. This one's bigger than this one. Make sense? All right. So what do you think I'm going to do here? Two big tick marks and what? Two little tick marks. You got to say it like that. Two little tick marks. All right. And what's true about A and D? What do we say about A and D? They're equal to each other. All right. So what do you think we might call this one? Good. I'll call it side angle side. What? Do I just call it side angle side? No, I call it side angle side similarity because our normal side angle side meant that AB was equal to DE. That's not true here, okay? And that would have meant the triangles were congruent. We don't have equality here. We have side, side, side similarity. That's also a theorem. Not that I really care that you know that, but... So we'll just call it side, side, side similarity. Don't just put side angle side similarity. Why does the angle go in between? Why didn't we put side, side angle? Because look where the angle is. The angle's between those two corresponding sides, aren't they? Do you see it? There's your side, there's your angle, there's your side. It's in between those two. So this wouldn't work if all I knew that angle B was equal to angle E. If I didn't know A and D were equal, all right, pretend I didn't know this and this, but I did know this and this. Could I say side angle side similarity with that? No, I couldn't. All right, I couldn't do that because why not? That angle's where? Or where is it not? It's not in between. It's got to be in between. So angle A and angle D. So if it's in between the two sides that they give you right here, then what do you think is true about the triangles now? They're similar. So now I can say triangle ABC is similar to triangle DEF. All right, should be catching on now, right? So those are our three ways. We had angle-angle similarity, we had side-side-side similarity, and we had side-angle-side similarity. And that's the kind of stuff that you need to know. Let's see what else. Tell you what, this is about where we left off. We still have a couple minutes, but this is about where we left off in the other class. This is where I'm going to stop right here. I'm going to give you a worksheet. You should be able to do most of it. Now, if I had like another maybe 10 minutes, I'd do an example or two. All right, and that would really help you with a worksheet. But if you want, you could always look in the book if it helps at all. I see some examples on page 476 and 477. If you want to check those out, you can. Try to do as much of this worksheet as you possibly can, and we'll go over a little bit more tomorrow. All right, so just to solidify what we were doing here. All right, that's it. Let me give you the worksheet, and then we'll be done.